Have you ever heard someone ask, how am I ever going to use algebra in real life? Why is this important? Well, this is Mrs. Earl with a short tutorial on how we can use linear equations to solve real-world problems. For our first example, we have Nicole, who's babysitting. She charges a flat fee of $3 plus $5 per hour. We are going to write an equation to show the cost y after x hours of babysitting. How much will she make if she babysits for 5 hours? So let's start with the basic linear equation. Y equals mx plus b. Now b is the constant rate she makes of $3, regardless of how long she babysits for. But we also know that she makes $5 per hour. $5 for each hour. We can put in any number of hours here, and that will give us the total amount she makes. So for the question, how much money will she make after 5 hours, we could rewrite the equation, $5 per hour times 5 hours plus her $3 basic fee. And in fact, we will find that after 5 hours, Nicole will make $28. Y equals 28. For our second example, Rufus collected 100 pounds of aluminum cans to recycle. He plans to collect an additional 25 pounds each week. Let's write an equation for the total number of pounds he can collect over X number of weeks. So we know that he already has 100 pounds, so that's our B, plus 25 pounds each week, substitute in for 25x, and that will give us the total number of pounds that he has collected over a specific number of weeks. Well, the story wants to know how long it'll take him to collect 400 pounds of cans. 400 pounds is the total, so we're going to substitute it in for y, which equals, remember, 25 pounds per week, and he already has that 100 pounds. So we now can just solve that like any equation. Subtracting 100 from each side gives us 300 equals 25x. And then we divide both sides by 25. Do you have the answer yet? And the answer is 12 weeks. X equals 12, and X is the weeks. It will take him 12 weeks to collect a total of 400 pounds of cans. Now let's take a minute and graph the equation. We start by knowing that Rufus has collected 100 pounds of cans. That would be our y-intercept here on the graph. And then he collects 25 pounds each week. So after the first week, he has 125 pounds. The second week, 150 pounds, and the third week, 175 pounds. We can continue this graph indefinitely, or for as long as Rufus decides to collect cans. Notice we don't go into the negative portions of the graph because you can't collect a negative amount of cans and you can't go backwards in time.